In order to create a policy-based data management system, computer actionable forms for data, information, knowledge, and wisdom are needed. Digital libraries work with the concepts of data, information, and knowledge. A data object is a string of bits. Information is treated as metadata that is associated with the data object. Knowledge is treated as relationships between items of information. In the IROD's data grid, computer actionable forms were developed to support the manipulation of data, information, knowledge, and wisdom. Data is any object that can be turned into bits, and it's stored as bytes. Information is any time a name is applied to an object, and it's stored as metadata. Knowledge is a relationship between named objects, stored as procedures. Wisdom is relationships between relationships and are applied at policy enforcement points. The manipulation of data, information, knowledge, and wisdom is done through well-defined computer operations. We manage data as bits, and they're manipulated through the POSIX I/O standard. We manage information as metadata, and it's manipulated through queries on a relational database. We manage knowledge as procedures, which are applied through workflows. We manage wisdom at policy points, which are applied through meta rules and policies. Note that information and data represent static objects. They are defined and stored. Knowledge and wisdom represent active processes that require the execution of procedures. The management of data then reduces to the management of strings of bits. There is no information associated with the string of bits. An object could be a file or a rule or a workflow or an application or query or a data sensor stream. All of these objects can be stored as a string of bits. The strings of bits can be stored in file systems as files or in databases as binary objects or on tapes or in object stores. Data can be manipulated using the POSIX I/O operations of create, open, close, unlink, read, write, seek, sync, stat, fstat, makedir, removedir, changemod, opendir, closedir, and readdir. These operations have proven to be sufficient for manipulating data. Information is generated when an object is named. The decision for which name to apply requires the evaluation of knowledge procedures. For example, in the room you are in, there is an object that satisfies the following relationships. It spatially is oriented vertically. It structurally is hinged on one side. It responds to the process of opening and closing. Based on these spatial, structural, and procedural relationships, the object can be assigned the name door. We now have generated information by evaluating a set of relationships. Every time we reference an object by a name, we are using information. Information is static. When we evaluate the relationships again, we expect to get the same name. Thus, a name represents the instantiation of a set of relationships. This process is called reification. We can store information in a database as metadata attributes. We have seen multiple pieces of information that are associated with files, users, resources, and metadata. Each metadata attribute was generated by a procedure which evaluated a set of relationships. Digital libraries normally concern themselves with semantic and logical relationships. Ontologies are developed that express the relationships between names. In order to build a computer actionable form of knowledge, we need to consider a much broader set of relationships. These include logical or semantic relationships on names, spatial or structural relationships on space, temporal or procedural relationships on time and causality, functional or algorithmic relationships on mathematics, class or category relationships on organization, epistemological or systemic relationships on systems. Relationships are captured in procedures that can be applied to named objects. To evaluate a relationship or apply knowledge, the procedure must be executed. When rule procedures are executed, the data grid is applying knowledge. Information is the result of the reification of knowledge relationships through the application of procedures. Knowledge has a recursive property. In order to apply relationships between named objects, the names have to be previously created. The creation of the names of the objects required the application of knowledge relationships. This appears to be an infinite recursion. We get out of this trap through education. We are told the names of objects without having to apply the underlying knowledge relationships. This works if information is static. What you learn in kindergarten is the basis for your ability to apply knowledge. On the other hand, your teachers had to learn the knowledge somewhere to teach you the information. The standard form of wisdom is the application of temporal and spatial relationships to decide when and where to execute knowledge relationships. Thus, the decision for which knowledge procedure to execute is a form of wisdom. The data grid captures wisdom at the policy enforcement points where the form of knowledge to apply is captured in policies. Originally, the IROD's data grid had to implement a static form of wisdom. The policy enforcement points were hard-coded into the software. With IROD's version 4.x, the application of wisdom is now an active process. In the pluggable architecture, new policy enforcement points are automatically generated for each plugin. By using the meta rules, the knowledge relationships that are applied at the new policy enforcement points are automatically selected. This means that the control mechanisms within the data grid can evolve along with the knowledge procedures, the information context, and the data. A data grid captures the wisdom and knowledge needed to manage a collection by using policy enforcement points that control the execution of procedures. Instead of imposing a specific set of procedures driven at a specific set of locations within the data grid, new wisdom and knowledge can be added dynamically to the data management system. A data management system can evolve to handle new types of data, new types of information, and new types of knowledge. Through virtualization layers that manage interactions with the external world, data grids can manage distributed data, manage information about the data, apply knowledge procedures to generate information, create policy enforcement points to control when and where knowledge procedures are executed. Take 7 minutes to answer exercise 29. Identify the wisdom needed to control a collaboration. This includes when and where knowledge procedures or rules should be applied. Consider whether a policy should be enforced immediately or deferred for application after other information is generated. Please load a paragraph describing your conclusions into the Lifetime Library in the subcollection class INLS 624 by the end of today's class.